Master's of Computer Science student. I'm going to be taking you through the EDA of the viral load data for drug resistance prediction. As the introduction states, drug resistance occurs when HIV patients they develop resistance to the art drugs, which lead to drug failure. And as a result, there has been a need to analyze and find out why they are failing on their drugs. So that's a prediction model to find out which patients are highly likely to move from first and second line forms of treatment. For the purpose of this presentation, I'll be moving between these slides and the actual code. So EDA was performed on a dataset for the year 2021, which had viral load test data with approximately 1 million results. When we go back to the code here, which shows the libraries that we are using, which is pandas, matplotlib, seaborn, random numpy, scikit-learn. From what we see, we used the pandas profiler library function after reading the data into a data frame. We run a profiler the function, which gives us a good description of what data we are dealing with. When we run that function, it showed us that we are dealing with a dataset of 1,048,000 records. The number of fields or variables were 12. We didn't have any duplicate rows. We didn't have any missing cells. And what you also see is majority were categorical, and we had one numeric variable. It also goes ahead to break down for us in detail the statistics. It shows us the cardinality. It shows us the fields that are uniform or unique. It gives us a statistic on, let's say, gender, the total number of female and male. It also goes over to show us those columns that have some form of interaction through the correlation graphs here. Yes. I will move over to show you when you run the data frame head function, it gives us the columns and their content. So when we do data frame dot types, we get to see we're still looking at exploratory. We get to see each type of the data type for each column. As you can see, we have one column. We have one column here that is an integer and the rest are objects, as we are seeing here. The one column here is integer and the rest are objects. When we run the data from the describe function, it gives us a summary of statistics, such as the count, the number of entries, which are all the same, which is 1,048,000. It gives us the mean, it gives us a standard deviation, the minimum, and the different quartiles, and then the maximum value. When we run the data from the info function, it still gives us the similar results as the other functions have given us. The total number of entries, there's no null entry. We see the data types for each column. As you can see, we are For this particular analysis, we're again focusing on using the regimen column, and other regimen, gender, and treatment initiation columns. So when we run this command here, data from current regimen.unique, it gives us the entries in that column, which are the regimens for treatment. When we do a count, we get to see how the breakdown along which regimen has which number. As you can see, it is the first line regimen which has the highest number, followed by the rest. So before we could perform any form of outlier analysis, we had to do some encoding, which was to convert the object to binary figures that can be read by the different functions like cbond, different libraries such as cbond to generate heat maps, and the box plots and the rest. So we went ahead and encoded the regimen column, we encoded the gender, and we also transformed the treatment duration. When we run again the data frame tail function, we got to see that the gender column had a change in its values. Treatment duration had also a change. The current regimen also now had a change. They're now in figures. So which allowed us to, and then once we run this command of unique, we confirmed that we no longer have the text, but now we have unique values, columns. Same for gender and regimen here. So which allowed us now to run the heat map. But initially, we first ran the box plot. We ran the box plot and we compared current regimen as the dependent variable against the suppression. And our box plot looks like this here, and it had so many outliers. Now in our y-x plane, we have 0 and 1 as patients who are suppressing, and above 1, which is 2 and 3, are those that are non-suppressing. As you can see, there was a high outlier, very many outliers of patients who were not suppressing, which would call for some improvements here in the data, as this can skew our model. So when we go over here to the heat map, we perform the heat map using the cbond library on the entire data frame. But if you recall, the data frame is going to be using the columns that we have transformed, which is gender, treatment duration, current regimen, and suppression. And it shows a very high number of patients who are suppressing. We also performed the scatter plot on regimen versus suppression, and it showed an underfitting sort of situation with horizontal straight lines. Now we move over to performing a train test and split, that is with a scikit-learn model selection. So we performed that and we gave the test size 30%, 0.30, and a random state of 10. Once we run that, we checked the length of the Y train, which was 70%, which showed 734,000 of the 1 million entries, which is a sign that this function ran a train test split. Then we performed a linear regression. We wanted to perform a fit on this data that we had trained and tested. So we ran a linear regression, which was successful. Then we checked the prediction of the X test. This was the result. When we did the prediction on the Y test, that was the result, where there was a huge gap. And when we ran a score for prediction, it showed us that we had a very poor result with our model, which means we shall have to keep tuning this. So for the hyperparameter tuning, we used SVM, support vector machine, and we imported the grid search. And once we performed the grid search, unfortunately it ran for a very long period of time, but which also gave evidence that we have to improve the data and the model and keep testing it and improving it until we get a good result. So with that, I thank you, and that is the end of my presentation.